Every day, consumer products are dropped more often than we expect, and predicting how they behave during impact is a real challenge for engineers. These events happen in milliseconds, making it extremely difficult to rely on intuition or late-stage physical prototype testing. In this video, we'll explore how virtual drop test scenario in SolidWorks simulation helps engineers to assess the impact behavior early during their design stage. Using a camera casing as an example, we will visualize stresses and deformations during a drop event. When you can see a product, how it behaves during impact, you can design it to survive real-world use. We begin with camera casing CAD model exactly as it exists in the design environment. By working directly on the design geometry, engineers can evaluate impact behavior early without translating data or waiting for physical prototypes. Next, material properties are applied to represent how the camera casing responds during impact. Material behavior is important because it directly influences how impact energy is absorbed when the product hits the ground. To accurately capture impact behavior, contact definitions ensure that the camera casing interacts correctly with the impact surface during the drop. At the same time, mesh refinement is applied in critical regions, so stress concentrations and deformations are captured accurately, especially around round edges and corners where failures often begin. The drop scenario is defined by specifying gravity, drop height, orientation, and the impact surface. This allows engineers to recreate realistic usage conditions rather than relying on assumptions. With the setup complete, the simulation is run to let physics determine how the camera casing behaves during impact. This replaces guesswork with calculated results and clear visual insight. Stress results reveal where the highest load occurs during impact. These plots help engineers identify regions that are most likely to crack or fail under real-world drop conditions. Deformation results show how impact energy travels through the casing and how effectively critical areas are protected. This insight helps engineers evaluate whether the current design meets durability expectations. With this insight, engineers can confidently adjust geometry, thickness, or material selection early in the design process. Making these designs early reduces physical prototypes, shortens development cycles, and lowers overall risk. In this video, we have used camera casing as an example to visualize how impact loads move through a component during a drop. By running a virtual drop test study, we gain insights into how a design behaves before building physical prototypes. This early visibility helps engineers reduce physical prototype testing, avoid late-stage design changes, and improve product quality. The same simulation-driven approach can be applied across structural, thermal, fluids, plastics, and electromagnetic simulations with SolidWorks simulations and similar suite of solutions. The key takeaway is simple. When you can see how a product behaves during impact, you can design to survive real-world use. If you would like to explore how simulation can help your product, connect with us.